Greetings dear friends, welcome back to my YouTube channel. Hope you guys enjoy all my videos. So today we're going to see something very new and very interesting. This time around we're still programming PIC16F877A, but we're going to be interfacing it not with LED but with an LCD, as you can see in the simulation. So basically here is a connection which I'm still going to explain, but before going to the connection and the code, let's get to simulate and see precisely what it does. As you can see, simulating, it displays a movie text, that's a text moving to the left saying welcome to Arduino.tech, please subscribe. So make sure you subscribe and click on the notification bell to keep track in all our upcoming and enjoyable videos as an engineer. So basically today here is what we're going to be doing. Follow with us as we continue. So let's stop the simulation and get to the explanation of circuit. Okay, zoom in. As you can see, real life LCDs, you are going to find out 16 pins, in which the two other pins which are not here are for the back LED, that's the backlight for the LCD, which in this case is not really it's not really important because we are dealing with just seeing the text being here. So basically the first pin here is being named VSS. Yeah, and VSS already is an expression for being grounded. So that's what we have at the ground. VDD for being powered, and this our power here is at 5 volt. Make sure yours is at 5 volt. Hope you guys know where to pick the components. It's not something we're going to be doing by now, just explain our circuit. And VEE here enables the LCD to be controlled by a potentiometer, as in the brightness will be controlled by a potentiometer. You are not going to see any difference in Proteus because Proteus don't really deal with that, but in real life simulation, that is in practical real life simulation, you are going to see as you are turning or varying your potentiometer here, is going to be varying the brightness of the LCD. And to follow, we have RS, which goes next to a digital pin. I started with RB1, so make sure the digital pins you are going to be using here are exactly the ones you use in your code. We are going to see them in our codes. And RW here mainly goes to the ground. E now enables, it goes down to the next digital pin. You can use any other digital pin, but making sure that you don't get to confuse them in your code. So pin wise, make sure you put them in ascending order, avoid confusion. And pin D0, D3 are being skipped for some precautionary reasons. Check that on Google. Okay, and D4 to D7 are connected to digital pins. So basically that is all for the circuit. Yeah, and let's get right now to the coding. That's the most interesting part. So basically I wrote the code already, but I'm still maybe going to rewrite it for you guys to understand. So let's see how to create a new project. Then you say next. From next now you need to give your project name. I'm just going to say LCD project. Yeah, why give the name? Make sure there are no spaces. For my device clock, I'm just going to say 4 megahertz. You can choose yours, depend on how fast you want your microcontroller to process information. And you choose the destination folder. That is mine. From there I say next and I say finish. Okay, so basically here is my workspace. So basically for these guys, you guys are just going to see them here like this. Okay, we'll get right now to explain the meaning of all of this. They ask you to save your work, so preferably save it. Okay, here right now we're initializing each pin of the LCD which was connected to the microcontroller. And like I told you, you had to take good precautions of where you were connecting them. As you see, mine were at RB1, RB2, RB3, RB4, 5 and 6. So why naming them or why initializing them, you use the keyword S bit, and when you use the keyword S bit, you use the name of the pin. That is here. You could take note that were written right, RS D3D. That's why you assign them with underscore RS underscore EN. As you can see, EN is the same as with the E we have here. Yeah, it's the same as the E we have there. And then from there right now, sorry for that. From there now you have initialized all of your pins on the LCD. After initializing them using the S bit, you need right now to show their direction, in which their direction right now is in the trace B of port B, because basically they are connected to the digital pins of port B. So that is all for the LCD initialization. Okay, so like I said already, we are going to be doing the coding together, and we've initialized the different pins of the LCD, as in where they are connected to the port B, and we've shown their direction to trace B. That's each of their bits. That's bit 1, 2, 3, 4, 5, and 6. So proceeding right now the coding. Basically we are doing this coding together because I want you guys to see the different LCD keywords and the different LCD commands. So getting started, we need to first of all initialize our LCD by saying LCD init, that is initialized, and leaving empty braces, and then we close. Once we have set LCD init, we send a command to set the cursor off, yeah, before anything gets started. So to send that command, we're going to use underscore LCD. So once you are sending a command, immediately open the braces, you use underscore LCD. That will be for all the cases for the LCD command. So LCD underscore, here right now we're going to set the cursor off. So set cursor off, and we say off, yes, semicolon. And the next one right now, let's just clear our LCD to make sure that there's no initial character in it. So to clear LCD, you still say underscore LCD underscore clear and the semicolon. So basically these guys are going to be repetition. So let's just copy it for now and keep it. So we've initialized our LCD and we've cleared it all. So now let's send the text we want it to print. That is simply by using the keyword or the command LCD underscore out. That is all. So LCD underscore out, we're going to have comma 1, comma 1, whereby this 1 here stands for your text will be displayed on the first row and the first column. Yeah, basically if you recognize on LCD here, it can display just 16 characters and 2 lines. Yeah, you can have just 16 characters and 2 lines. So basically we need to send an information that is not greater than 16 characters, but since we are scrolling the text, that is we are shifting it left, yeah, we can send something of more than 16 characters without having any issue. So from there now you put in your colon, your hyphen, sorry, whatever be the case, and the text we're sending now to our LCD was welcome to Arduino Tech, and we're asking please subscribe. From there you close your double quotes and you close your braces. Make sure you put your semicolon. So basically here is the LCD out. Once the LCD out is done, you can place a delay of few seconds before it starts scrolling or start shifting to the left. So basically I just place a delay of 200 milliseconds, that's 0.2 seconds. So after placing your delay, you need to start shifting to the left. So we are going to use a command, still the LCD underscore CMD, that's a command. Sorry, I forgot I copied it already. So LCD underscore So here we're going to talk about shift. You can either shift left or shift right. But for our case, or for my case, I choose shift left. You can modify your code, and it says semicolon. So it's shifting left, and for you to recognize the shifting left, you need to place a delay because it's usually very fast. So basically my delay is still of 200 milliseconds, and I place a semicolon. So that is all for our text to be shifting left. But right now, according to this code, it's going to execute just once. So for it to execute infinitely, that is continuously, we saw this already in our previous code, we're going to put a while loop, that is with a value 1, which will be causing an infinite loop. So you come down here to close the braces. Close the braces of the while loop. Okay, it was already been closed. So the brace of the while loop has already been closed. And from there, while loop is closed. And basically, after this, right, after the text display to the left, you need to come back to the initial statement. Welcome to Arduino.tech. If you recognize, yeah, let's see it here, you see, right, it comes back to its home format. So we're going to place a for loop where it's going to be executing. In this for loop now, that is where it's going to be executing. We can talk about a certain I with initial values 0, and our I here is less than or equals to 45. We're going to talk about a 45 maybe later, and we have I plus plus close the braces, and we put it in our for loop. We close the braces now for the for loop. Okay, so like I said, we're going to talk about the I being 45 later. So the I, reason why we're saying less than or equals to 45 is counting the number of characters in which you are actually shifting. Yeah, the value you are putting here is the number of characters minus 1. So you can count yours. I don't know how many it is actually, but I just place a guess value there. So that's actually the number of times our code or our text is being shifted to the left repeatedly. So after shifting to the left repeatedly, you need to come back to its format. That's LCD. For it to come back to its format, we still send another command, LCD, and we say LCD underscore return home. So once it returns home right now, it restarts back the process and everything proceeds. So for it to return home and for it to recognize the return home, you still need to place a delay of milliseconds. This, yeah, so I set mine to 200 milliseconds. Okay, that's all for the code. Yeah, hope it was very straightforward and easy. And after that, now you need to come to your library manager and talk about your PIC microcontroller. Select the library for the LCD. Here it is, as you can see. You click on it. I hope you guys can see it very well. You click on the library for LCD. Once you have clicked on the library for LCD, let's build our code if there's any error. The first error is that we haven't initialized our I. So you get to initialize it here, or anywhere in your code. It won't disturb at all. Okay, the building was successful without any error. So let's come back to our circuit to upload our code. So uploading our code now. Hope you recalled where you saved your work, because mine, it was saved at desktop and all important folders in which it is already. So you double click on top and say okay. So let's see if our code reacts accordingly, else then we recheck our code. Okay, you can see basically that is it. That is the result we are expecting from the code. The text is scrolling exactly as we want. So thanks you guys for watching. Hope the video wasn't too long, but it was to break down the explanation deeply. So in the next videos, I will just be coming with the codes at once written already to avoid longevity in the videos, because sometimes it boils. So if you have any question, please ask them in the comment section. they are going to be answered in the next videos. Thanks you guys very much. Please subscribe to the channel to keep track in the next videos coming and the next enjoyable stuff coming in the video. Click on the notification bell, I beg.